Good morning. Can everybody hear me? Okay. Almost exactly 2 years ago, in 2016, in the summer, we had the Olympic Games in Rio de Janeiro in Brazil, bringing about 500,000 spectators and visitors from all over the world to Brazil. And around that time, actually, probably starting in the fall of 2015, at the same time, there was also a spread of the mosquito-borne infectious disease Zika, raging in the Americas, including Brazil. And up to spring 2016, there were around 600 cases of babies born to mothers who had gotten infected with the Zika virus during pregnancy. And the Zika virus can cause deformations to the baby with the head and impose severe limitations to the health and the life of the baby. And because of this risk, potentially, to the visitors coming to Rio de Janeiro, there were calls to potentially postpone or even cancel the Olympic Games in Rio de Janeiro. And the mayor of Rio de Janeiro at that time, Eduardo Paes, he brushed off these concerns in an interview saying, there's the issue with pregnant women and this is something we need to take care of. But I don't know anyone who's got the Zika virus, and I know a lot of people. So this is not a big issue. And eventually, Paes was right. There was not a single case of a Zika infection among the spectators of the Olympic Games 2016. But still, this claim of his was perceived as relatively bold and smug. But at the same time, Paes was also doing something that we do intuitively all the time, namely that we're taking a small slice of the experience we have from our own social world and make inferences based on this thin slice of our own experiences in our social lives. So we are doing some kind of social sampling to make inferences about the world at large. And this approach to make inferences about the global environment, social environment, based on the immediate social environment that we have around us is something that might be important and informative for many other different kinds of things. For instance, when we're trying to make inferences about the relative popularity of different products, so who's got an iPhone, who's got a different kind of phone, or to form ideas about the distribution of different opinions in the environment. We don't know what everybody thinks in the environment, but we have observations of these events in our social environments, and we might use these direct observations in our social environments to make these kinds of inferences. And this idea of social sampling is also or has entered the judgment decision-making literature, in particular in the model of the availability heuristic by Thorsten and Kahneman, according to which there are situations in which people assess the frequency of a class or the probability of an event by the ease with which instances can be brought to mind. For instance, one may assess the risk of heart attack among middle-aged people by recalling such occurrences among one's acquaintances. So this is social sampling. It's the idea underlying the availability heuristic. And there are also a couple of important and prominent judgment phenomena in the literature that also take up this idea of social sampling. For instance, the false consensus effect. Many of you will know this from textbooks. The false consensus effect basically assumes that in order to make inferences about the prevalence of behaviors, we take a very, very, very tiny sample of the world, namely ourselves, and generalize from whether we are carriers of a particular, or whether we show a particular behavior, and use this information basically to make inferences about the world. And Ross and colleagues describe the false consensus effect as follows. The person who feeds squirrels, votes Republican, or drinks drambuie for breakfast will see such behavior as relatively common. A second example that also illustrates the power of social sampling is work on judgments of risk frequencies, where the question is how people judge the frequency of different health risks, like in the Zika case, for instance, in this classic work by Lichtenstein and colleagues. And this work has shown in several replications that we did afterwards, was shown that people's judgments about the frequency of such health risks in the population is strongly correlated with what people report as experiences of these risks in their own social environments. So this is another manifestation that people apparently use the observations they have in their own social networks to make inferences about the world. And more recently, also there's work again illustrating the idea of social sampling. In this work, for instance, by Mirta Galesic, who asked people to judge the distribution of different events in the environment. For instance, how many people there are that have a low or high household wealth. Here you can see the actual distribution. So there's relatively many people with relatively low wealth in the population, and very, very few people have very high wealth. And people were asked to estimate this distribution. And here you can see people's estimated distributions separately for people who are themselves relatively worse off, here in the blue line, and for people who are themselves better off. And you can see that these estimated distributions diverge. And what Galesic and colleagues also did is they asked people to indicate what distribution they themselves observe in their own social networks. And you can see that here as well, they really live in different worlds, basically. So when people are asked to report the distribution of wealth in their own social circles, people who are themselves well off or worse off or better off, they report different kinds of distributions. And potentially, they use these observed distributions in their own social networks when making generalizations about the distribution in the population. So this is another instance where people potentially use observations in their own social networks to make judgments about the world at large. And the question is, however, after we've seen these different examples of social sampling, what guides this social sampling? Is it the case that people just exhaustively, basically, recall everybody they know from their social network? Or is there some kind of structure in terms of how people retrieve these instances from the social networks? And also, is it the case that people use and retrieve all the people they know, or is there also evidence, as we've learned over the week, that people use only part of the information they have potentially available and retrieve and access only part of the social knowledge, the instance knowledge they have when making these kinds of inferences. And this is one of the issues I would like to address in my talk. A second issue I would like to address in my talk is how, if there's evidence for limited social sampling, that is, that people don't retrieve everybody that they know in their social networks, how can one model this limited social sampling? Is there potentially evidence for a non-compensatory retrieving process, as you have heard in this week, for instance, in the case of the take the best heuristic that also only looks at part of the cues? Can we see a similar logic also in the retrieval of instance information when people are using social sampling in order to make inferences about the world? And the third issue I would like to address in my talk is to what extent there might be an ecological rationality to limited social sampling. As you've heard, the idea of ecological rationality means that certain cognitive mechanisms might be particularly suited to particular ecological structures in the world. And the question is, are there ecological structures in the world that foster or that help limited social sampling to be actually pretty successful? And this is the third issue that I would like to address in my talk. Okay, what guides social sampling? Is there other potentially structures that might guide when people are accessing memories of the people they know? A couple of years ago, I did an experiment with my own social world. For more than 2 years, I kept a diary of every single social encounter that I had. And social encounter was defined as talking to someone for longer than 5 minutes, or speaking to someone on the phone, or writing more extensive email. I did this for every day of these slightly more than two years. These were 740 days. I had contact over this time with, as defined, to 351 people, and there were overall a total of 3,500 social contacts. Now the question was, how were these social contacts distributed among the people that I had contact with? So these were 350 different people. Was it the case that these social contacts were spread relatively equally? That would mean that every of the people that I encountered had about 0.5% of the social contacts. Actually turned out to be not that way. And actually, about 12% of all the social contacts I had during that time were with one single person. And actually, about half of this total of social contacts that I had were only to 14 different people that I had contact with. And the other 330 I had very, very less contact with. So social contact is very structured and it's very focused. And one important reason for this is, of course, that people in our social lives have roles. And Kahn and Antonucci, in work on social support, proposed that in order to illustrate or to represent these different roles that people have that might be driving these differences in how frequently have contact with a person, can be represented in these terms of concentric circles, where we are in the middle and we're surrounded by our family, by our partners, by more distant family, and then neighbors, work colleagues, acquaintances in more distant circles. And these different roles that people have in a person's social life might be responsible for these differences in social contact. Now, the question is, to what extent might these social structures, so the differentiation in terms of myself, family, partners, friends, and acquaintances, to what extent these social structures might be important for guiding social sampling? And Thomas Hills and I, we investigated this by running an experiment where we asked people to report, by typing in the names, of the people they know. And they weren't structured or constrained in any way how they do this task. They could enter the names in any order they wanted to. And what the participants didn't know in the beginning of the experiment was that we stopped them after 35 entries. So, and then after people reported these 35 names, we also asked them to indicate to which social category these different people that they recalled belonged to, and how frequently they had contact with these different people. Okay? And here's the data of a representative participant. Here you can see the order in which these different people were entered. You can see how long it took basically to enter the name. And indicated by the color, you can see to which social category the person belonged to. And so that person started with his or her partner, followed by a friend in green. And then there was a long string of family members being recalled. And then there was a long string of friends being recalled. And then later on, also some acquaintances were recalled. And so one thing you can see from this data is that social retrieval or social sampling is highly structured apparently by the social categories to which the people belong to. And what you can also see is that each time a new patch or new category was entered, response time went up. It might indicate that people are really jumping between different patches in their social environment when they are retrieving people from the social memories, basically.
What's the difference between the empty circles and the solid circles?
They're just too small to be empty. Okay, and here you can see the aggregate data. So here the rank order of recall for partners, family, friends, and acquaintances. And you can see that partners were on average retrieved relatively early in the retrieval process, followed by family, friends, and acquaintances. And you can also see that partners, that's not very surprising, also had the highest frequency of encounter, followed by actually friends, slightly more frequent than family and acquaintances. So social recall seems to be structured by the social categories. So there seems to be a lot of structure that potentially might be exploited also by judgment mechanisms that rely on social sampling. And we implemented this idea that when making judgments about the world, we exploit social structures in a model that we call the social circle heuristic. And the social circle heuristic is a model that tries to describe how people make inferences in paired comparisons between two events, basically. So, for instance, when you are asked which of the two health risks is more frequent, skin cancer or lung cancer. So it's for paired comparison. And the idea is that in order to make such an inference between these two events, you're accessing your social memories for relevant instances of these events. And the social circle heuristic starts with circle 1, which is the person, him or herself, and asks, am I myself someone who was afflicted or is an instance of one of these two events? And if that's the case, all other instances in a person's social memory are ignored and an inference is made. This is similar in spirit to the false consensus effect. So an inference is solely based on the information that the person has about him or her self. If that's not the case, if that first circle does not discriminate between the two events, it goes on to the next circle, which are family members. And again, the idea is that instances among family members are searched and counted. And if the number of instances for one of the two events discriminates between A and B, the event A and B, again, all the other instances are being ignored and an inference is made. And if circle 2 does not discriminate between the two events, it goes on to circle 3, which are the friends, and so on and so forth. So here we have an instance of a non-compensatory inference mechanism that sequentially samples through a person's social network, through different circles, and makes an inference as soon as the amount or the number of instances within a social circle discriminate between the two events.
Yeah, my question is, does this heuristic only apply to event categories to which people have very limited previous knowledge? Because if people would ask me which is more frequent in the population, volleyball or soccer, then if I apply the circle heuristic, then I would say volleyball, but I know that that's the wrong answer.
Yes. So, I mean, this is a model of how people might use this, and there might be boundary conditions under which people refer to such a sampling-based strategy, and there might be other conditions where people use a different strategy, potentially because they have direct information about the event frequency. So if you know, because you've just read it in the newspaper, how frequent these different events are, then you don't need to enter such an inference mechanism. So this is about judgment decision-making under uncertainty where you don't know the correct answer. And you have to make inferences based on proximal information or cues, or here, instance knowledge. Okay, so this is an idea of how social sampling might be implemented in a non-compensatory way, and where social structures are being exploited to guide and terminate social sampling, the search process within one's social memory. And we tested the idea whether that actually is a valid or viable description of behavior in an experiment, where we compared the social circle heuristic, as I just described it to you, where the circles are being defined in terms of the social categories, self, family, friends, acquaintances. We also tested a variant of the social circle heuristic where the circles were defined by the frequency of contact. So a different definition, basically, of the different social circles. And third, we also tested a model that does not implement this non-compensatory process, but retrieves all the information, all the instances that the person knows, and we call this model availability by recall. So this model basically ignores the social structures and always exhaustively retrieves all the instances that a person knows. And to illustrate this difference between availability by recall and the social heuristic, for instance, imagine that you're being asked, or someone who doesn't know the correct answer, whether table tennis or cycling is more frequent in the population, so whether there are more club members for table tennis or cycling in the population, and you don't know what the statistics are, so you consult your social memory. And availability by recall would just simply recall all the people one knows, so all friends, parents, oneself also, and colleagues, and compare the resulting numbers. And here in this example, there are more cases for cycling, 8, than for table tennis, and the person would then say, well, I think cycling is actually more popular. The social circle heuristic, by contrast, would search through the different circles sequentially, starting with the self. And here in this instance, for instance, a person plays table tennis and also cycling, so goes on to the second circle. Here, the person recalls 2 people who play table tennis, but not a single person who cycles, and then would ignore the other instances in the person's memory, make an inference, and actually judge table tennis to be more frequent. So this illustrates the difference between the exhaustive search implemented by availability by recall and this non-compensatory search process implemented by the social circle heuristic. In addition to these mechanisms that implement social sampling and make an inference based on instance knowledge, we also tested mechanisms that use semantic cues, like take the best, telling, or weighted additive, to make an inference. So these mechanisms ignore instance knowledge, so the people they know who are representatives of these different events, but try to or use features of the events in order to make an inference about the criterion. I'm going to illustrate this in a second. So here are the results about the experiments that we run. We had 40 people. People did an inference task where the question was, which of 2 sports is more popular in Germany, basketball or table tennis? And they made a total of 300 decisions of this type. After this inference task, people were given an instance knowledge task where they were asked to recall relevant instances for these different sports and also to indicate to which social circle these different instances belong to, so whether it was themselves, family, friends, or acquaintances. And we also asked people about the frequency of contact to these different instances in order to implement this variant of the social circle heuristic that uses frequency of contact to define the social circles. And finally, we also asked people to indicate their cue knowledge about these different types of sports. For instance, whether the sport was a team sport or an individual sport, or whether the sport was an Olympic discipline or not. And these features of the sports might also be correlated with their popularity. And we fed these semantic cues then into different cue-based models like take the best or telling in order to make an inference. And the key question was, to what extent do these different models of the inference process describe people's behavior in the inference task? Here are the results. So what I show here to you is for each of the 40 participants, BIC weights for the 6 different models and also for a guessing strategy that basically assumes that the person makes these inferences based on guessing. And the BIC weight basically, here represented in these different colors for the different strategies, indicates the amount of evidence that there is in the data for people using a particular strategy. So the bluer, for instance, or more blue is there, the stronger the evidence, for instance, for the social circle heuristic. And as you can see, there are clearly a couple of people here on the right-hand side that are better explained by cue-based mechanisms, such as weighted additive or tallying. But overall, there seems to be more evidence for people actually using social sampling or instance knowledge to make inferences about the relative popularity of the different sports. And in particular, among these different instance-based models, there seemed to be quite some support for this idea of limited social sampling as implemented in the social circle heuristic, as you can see that actually the BIC weight relative evidence for the models, the social circle heuristic and the variant of the social circle heuristic based on frequency of encounter as a definition of the circles actually received quite some support. So this basically illustrates that the idea of non-compensatory lexicographic search through one's instance knowledge exploiting social structures is a viable idea. However, one might argue, well, not everybody might search their social circles in this strict order of self, family, friends, and acquaintances. Maybe there are individual differences in terms of how these different social spheres are being accessed. And in order to accommodate these potential individual differences, we generalized the social circle heuristic. So this is work together with Christine Schulz, who is sitting over there. And the generalized model of the social circle heuristic that we call social circle model has 3 parameters that allow to express the importance of these different circles, that is, in which order these different social circles are being accessed. So there are 3 parameters for the self circle, for the family circle, for the friend circle, and the acquaintance circle. And these parameters can be estimated for individual participants. So this model allows that some person might, for instance, first access people in one's family rather than oneself. A second aspect that is being generalized in this model is that we allow the stopping rule to differ between different people. So basically we allow for differences in the amount of difference in the number of instances between 2 events that are necessary for the search process to be terminated. And this again can be estimated for individual participants. And then finally we also have a response error parameter that allows to take into account differences between people in the amount of noise that is there in the inference process or search process. And we tested this model, this generalized model of the social circle heuristic, in an experiment with the total of 112 adults, participants with 56 adults and also 56 children. And we focused here in this study in particular on kids because their instance knowledge compared to that of adults might be limited, and therefore kids might actually be more prone to perform a more exhaustive search. So this is actually a pretty tough test for the social circle heuristic or the social circle model. And also there's some evidence in the literature that kids might have difficulty implementing very structured search. So this has been shown in multi-attribute tasks, and potentially this might also mean that kids are less likely to rely on a sequential sampling process as implemented in the social circle heuristic. So we included these kids to submit the social circle heuristic or the social circle model to really tough test. And the participants made an inference task. Now it was not about sports, but we asked them to make inferences about the relative popularity of holiday destinations. So they were asked, for instance, which holiday destination is visited by more German vacationers, Italy or France? So they always make these paired comparisons for a large number of different holiday destinations. And after doing these inference tasks, so they did this for a large number of different items, we asked them about their instance knowledge. So we asked them to retrieve from memory people they know who had been in Italy or in Turkey or in the UK, and also to indicate to which social circle these different people belong to. And based on this knowledge, we were again able to implement and test the social circle heuristic, but also availability by recall. And just to give you an impression of what people reported in this experiment, so adults, that's not very surprising, recalled a larger number of different instances compared to the kids. And the adults were also somewhat more accurate in doing the inference task, that is, picking the holiday destination that, based on objective statistics, were indeed visited by more people than the kids. Okay, now the key question is, how did they solve this inference task? To what extent is there evidence that the participants, also the kids, implemented this sequential non-compensatory process that is being described in the social circle model. So here are the results for the adults. Blue, dark blue, represents the social circle model, and the lighter blue is for availability by recall, that ignores social structures and searches or samples exhaustively. And you can see that there's large support for the social circle model, and the social circle model is a better model apparently of people's inferences than availability by recall that searches instance knowledge exhaustively.
In your model for the availability by recall, did you also have a threshold level for stopping criteria?
No, we did have a response noise parameter, but not one for the threshold.
Have you considered how this might change if you include that?
We discussed this. If I remember correctly, it doesn't make much of a difference because the alternative of using all the information you have is guessing, basically. So, and also when you aggregate across all different social circles, most of the time you actually have a pretty large difference in the number of instances that are being recalled. That's not necessarily the case when you do the retrieval by the circles. Okay, and it would also increase the flexibility, of course, of the model. So for the adults, there's large evidence that people are using something along the lines of the social circle model that implements sequential non-compensatory search. And surprisingly, actually, that was also the case for the kids. So if anything, the kids showed even stronger support for the social circle model compared to the adults. So there's little evidence that the kids would have problems implementing such a sequential ordered search through their social memory compared to the adults. So both for adults and for the children, we have evidence that this idea of sequential social sampling to make inferences about relative frequencies in the population actually makes sense and is a viable idea.
How do you read those graphs on the y-axis? So how does it come? Some people have like mixed evidence for different strategies.
I mean, we determined these BIC weights basically express how much evidence there is for the different models. And of course, I mean, there are some cases where the evidence is very, very unambiguous and where it's really clear that one model does the best job, is clearly the best model or a better model in accounting for a person's data than another. In other cases, the evidence is more mixed. So there is some evidence for one model, but actually the evidence for the other model is somewhat larger.
But is it like samples or like on Markov chain, or what do you? So how does it work?
Oh, how it was calculated? Yes. So I mean, this was basically determined based on a model selection, a Bayesian model selection approach, where eventually basically you have. I mean, you can also calculate Bayes factors based on that. So there's relative evidence for the different models, and these BIC weights express how strong the evidence is for one model over the other. Okay? Okay. And finally, I said that the idea of generalizing the social circle heuristic by introducing these few parameters allows to capture individual differences, for instance, in the search direction or the search order through the different social circles. And as you can see here, which shows distributions for the different parameters for the adults and for the children, there is evidence for strong individual differences in the importance of these different weights or these different circles in the instance, in the search for instances. So some people indeed give the self circle a large weight and then consider the family as less important, but others actually start with their friends and give a lot of weight to their friend circle when searching for the inferences. So it really pays off to have a free parameter in the model that considers these differences in the importance of the different social circles in social sampling. Okay, so first of all, I addressed what structures in a social network might guide social sampling. And second, we also saw one proposal or actually two proposals, of how this limited sampling through one's social memory could be modeled in terms of the social circle heuristic or the social circle model. Finally, I would like to address to what extent this idea of non-compensatory social sampling might have an ecological rationality. That is, that there might be ecological characteristics, structures in the world out there, statistical structures in the world out there, that contribute to such a limited search being actually pretty good, or at least not bad compared to how the inference process would be if all the information would be searched. And we addressed this question using computer simulations, where we basically simulated social networks. So here you can see represented on a toroidal grid the social circle of a focal person here in the middle. So this dark circle here, this dark square here is the person herself, surrounded by circle 2 here in gray, in dark gray. And then we have circle 3 in lighter gray, and then finally circle 4 in these white squares. And we distributed events of different types here in color among these different people in that person's social network, with these structured by these different circles, and basically implemented an inference process that searched through these different social spheres in order to make an inference whether this is actually yellow, or for instance here the blue event occurs more frequently in the overpopulation. And the overpopulation the person didn't see, so this is just a glimpse. This is a person's social network, and this is the information that the agent has available to make inferences about the world at large. So overall in the simulation we used a very large grid with 100 by 100 agents, and we basically used this structure here to test the social circle heuristic and how well it would perform and how well it would judge the relative frequency of different events compared to a mechanism that always searches all the information that are available in a person's social network. And as I said, we're interested in this analysis in the ecological rationality. That is, to what extent a simple mechanism might benefit from particular ecological structures. And one social or ecological structure that we tested referred to the skew of the frequency distributions across the different event categories. So here, for instance, you have the frequency distribution of different cancer mortality rates, and you can see that this distribution is very skewed. So there's one cancer that is very, very frequent in the population, and other types of cancer are less frequent. And also here for the sports, we have one very dominating sport. You can guess what kind of sport that is. That's soccer. And the other sports, by comparison, are relatively infrequent. So we have, in real-world environments, often these very skewed frequency distributions. So the first ecological feature or characteristic that we varied in our computer simulations referred to the skew of the frequency distribution. So we had a very skewed distribution where there was one event that was dominating in frequency, and we also had a relatively flat frequency distribution where the decline in frequency was less steep. The second ecological characteristic that we manipulated in our simulations referred to the spatial distribution of the events in the population. And as we all know, social structures are often characterized by homophily. That is, people who have similar characteristics tend to be relatively close together in a social environment. And we had one environment basically where the events were completely randomly distributed, where there was no clustering at all. We had a second type of environment where there was a medium amount of clustering, so where cases of the same event were closer together. And we had finally two environments where the clustering was very high, where many cases of the same event were located in a very similar position in the toroidal grid. So we had a total of 2 times 3, that is 6 different environments that differed in the frequency distribution and the spatial distribution. And we tested how well the social circle heuristic and availability by recall, that searches all the information in a person's social network, when making paired comparisons among 2 events. And first, let me show you how frugal or not frugal the different mechanisms, the 2 mechanisms were in these different environments. So we have the 6 different distributions of 6 different environments, and availability by recall here represented in gray, because it always performs exhaustive search. It always considers all 41 agents in a person's social network. That's so by definition. And with the social circle heuristic, which has the stopping rule, as you can see here, actually increased search, so it had to search for longer before the stopping rule kicked in, from the random environment to the medium clustered environment to the highly clustered environment. But, and this is the most important aspect of this graph, you can see that even in the highly clustered environment, the amount of instances that were searched or sampled by the social circle heuristic was considerably lower compared to availability by recall. The social circle heuristic is much more frugal because it has a stopping rule. Now, the question is, what's the price that the social circle heuristic has to pay for this frugality, that it ignores information relative to availability by recall? So how does the social circle heuristic perform in terms of accuracy, judgmental accuracy, compared to availability by recall? So here on the y-axis, you can see the accuracy, the proportion of correct inferences for the different environments. Let's start with the random environment. And here you can see that the social circle heuristic actually pays quite some price for its frugality, and relative to availability by recall, it has substantially lower accuracy. And interestingly, when comparing the flat and the skewed frequency distribution, you can see that the social circle heuristic is somewhat better in the skewed than the flat environment, and for availability by recall, it's the other way around. Now, what happens if we introduce clustering in the environment, which is a property of the ecology that we often find in the real world? Overall, for both strategies, accuracy goes down. So it's harder to make inferences about the relative frequency of events in clustered environments relative to randomly distributed environments. Importantly, however, this effect is much stronger for the availability by recall heuristic compared to the social circle heuristic. The social circle heuristic does not have an as steep decline in accuracy compared to availability by recall. That really suffers from this clustering. And if we now finally look at the environment with a strong degree of clustering, differences in accuracy between availability by recall and the social circle heuristic disappear completely. That is, the social circle heuristic does not pay a price for its limited search. So, as you've seen before, the social circle heuristic looks up about 25 instances in order to make an inference. In the highly clustered environment, and the availability by recall strategy looks up 41 instances. And despite the frugality of the social circle heuristic, the social circle heuristic does not perform worse than availability by recall. Yes?
Also, looking at this, these were all binary choices, right?
Yes.
Which is better, or which is more frequent in the environment. Then in the flat clustered, highly clustered environment, both heuristics perform marginally better than chance level, right? At 60% accuracy. So does that imply that social sampling is maybe not that good of a strategy within these environments?
I mean, what is a good level of performance in these kinds of environments? I mean, what would you expect? Would you expect that a mechanism based on 40 observations of like over 1,000 can produce an accuracy of 95% is probably not very likely. So both of these strategies are confined because they only, even the availability by recall heuristic looks only at a small, relatively small glimpse of the overall population. And I mean, yes, 60% is not 90%, but I would still argue that this is actually pretty helpful performance. Yes?
Kind of following up on my first question, if you've shown that the performance is similar in terms of accuracy, yet the availability by recall uses 41 pieces of information,
yes,
where the social circle heuristic uses, for example, 20 in this situation. But that's by design. You're forced to build the recall to use 41.
Yes.
If you perhaps allow it to randomly choose various amounts until a certain precision threshold is reached, you could find that it's not worse than it might keep the same performance with only 20 as well.
Yes, but how do I mean?
It's a social circle. Once it's using that many, it's kind of. I mean, there's no, because it's about the population as a whole that you're making an inference, and not about your own proximal community.
Yes.
Sampling in an outward expanding fashion is no different than sampling randomly.
I can show you later an analysis showing that, I mean, you generally, of course, have a marginal decreasing accuracy. So you have, to some extent, always higher accuracy the longer you search. But the question is, how much does the increased search pay off? And that is a general characteristic here in these kinds of environments and for these kinds of questions. But I mean, for the availability by recall heuristic, how do you know in advance how much you would like to search?
That's what I'm saying. If, for example, the social circle heuristic is iterative. You start with a couple guys. It's not enough. You start with a few more guys. So you do the same thing, and you take a random sample of 5. If it's good enough, you stop. If it's not good enough, you take 5 more.
Yeah.
You keep going like this iteratively until you reach the stopping criteria.
Yes. And apparently this seems to be a smart strategy, what the social circle heuristic implements, in particular kinds of environments, but not in others. And now the question is, I mean, how can we understand that despite this very frugal search of the social circle heuristic, it does not pay a price? And in order to answer that question, let's dissect a bit more the accuracy of the social circle heuristic across the different circles. So here you can see for the skewed environment, separately for the random event distribution, clustered medium and clustered high event distribution, the accuracy of the social circle heuristics judgments separately for the different circles. So depending on where the search was stopped, whether it was stopped at circle 1, circle 2, circle 3, or circle 4. And you can see that when the search process, the social sampling, was stopped at the first circle, the social circle heuristic in the random distribution achieved an accuracy of 83%, and that decreased from circle 1 to circle 4. And that held irrespective of the clustering. Now, what changes, however, is that from the random to the highly clustered distribution, the proportion of times that search was stopped at the first or an early circle became higher. Okay, here you can see that in the random event distribution, the stopping rate where the search was stopped at the first circle that yielded very accurate judgments was only 21%. In the highly clustered, it was 35%. And that, of course, drove the performance of the social circle heuristic up because it stopped search more frequently at a circle that yielded a very high accuracy. Now you might say, wait a minute, accuracy decreases across the different circles. The circle 1 consists of one single instance. Here it's 4, here it's some more, and here it's a little bit more. So that's a little counterintuitive. So how can accuracy be higher at smaller circles than with larger circles? And in order to understand this, here I plotted the information about the difficulty of the choice that was being stopped at these different circles. So this is basically the relative difference in the actual event frequency. So it's the frequency between these two events normalized by the higher of the two events, the higher of the two frequencies. And the higher that number, the easier basically the comparison is. Okay, that is the relative difference between the two events in frequency is very large. That is, it's a very simple decision. And you can see that those paired comparisons between event A and event B that were stopped at an early circle were actually pretty easy ones, where the difference in the frequency was very large. And the harder ones, the harder events where the choice difficulty was higher, so where the delta is lower, was higher at larger circles. So the more difficult choices were basically passed on to later circles. And that makes sense because these later circles, they have more information because they are larger. So basically what you can think about what the social circle heuristic does is that it sieves out basically these very easy to solve decisions between two events that have very, very different actual frequencies at a very small sample size at circle 1, and passes on these more difficult cases and looks up more information, only those cases where a choice cannot be made based on small numbers of information. And this is basically an important reason why the social circle heuristic discards redundant information, only searches for more information if a decision is really hard and cannot be made based on small glimpses from one social circle. So, and importantly, so this was for the skewed distribution, this effect that these difficult choices were mainly decided on larger circles and the easier ones on small circles, only held for the skewed distribution but not for the flat distribution. And this also explained why, to some extent, the social circle heuristic performed better in skewed environments than in flat environments. Okay, let me wrap up. The first question I addressed in my talk, yes?
Question still. How do I know whether it's a hard or an easy task if I only have information about myself?
Yes.
Because I'm always either the one or the other.
Yes.
It doesn't matter if it's a 50-50 distribution or a 90-10 distribution.
The answer is you don't know. That is a byproduct, a side effect basically of the architecture of the social circle heuristic. You rely basically on what you see. And as it turns out, it's those cases that are being decided on the first sample that are relatively easy. The more difficult ones, they usually, especially in the skewed environment, these choices, these decisions are not being stopped at this first circle because there's not enough, or there's actually no instance that discriminates between the events. And as it turns out, depending on the structure of the environment, you have the effect that the simpler choices have a tendency to be stopped at small circles, and the more difficult ones are being passed on to later circles. The agent doesn't know how difficult the choice is. The agent simply looks at what do I observe in my environment.
But what is the stopping rule?
The stopping rule is does the number of instances that I observe in circle 1, for instance, different between event A and event B? If that's not the case, I go on to the second circle. Then I look how many instances are there for event 1 or event 2. And if that discriminates, then I stop and I don't go further in my search.
But in circle 1, it will always be 1 to 0, right?
No, because there will be many cases where I am an instance of something, but that's actually not relevant for the given question. So I might play basketball, but the question is actually about table tennis and tennis. So I am an instance of something, but my own social circle doesn't allow me to make an inference about these types of tennis. Does it answer your question? Okay.
Do you ever measure that? Like, do you let people ex post rate the difficulty of the choices? And that corresponds to what the model predicts when they start?
No, we haven't done that yet. I'm also not sure whether that predicts, whether the model predicts that. I mean, this analysis shows or illustrates why the social circle heuristic benefits from certain ecological structures.
But like the later model, the fully fledged one with the weight parameters, there you could predict when people stop, and maybe as a readout of how long the search process was, you see like confidence and difficulty rate.
Yes, that could be that based on the stopping rule, the differences in perceived confidence or difficulty of the choice. Yes.
Could you explain a bit more why it's better to do your search by circles rather than just a random sample from memory? Like, it seems like it's just an evidence accumulation model.
Yes.
But you're instead of choosing randomly, you're choosing by circles, but which is randomly with respect to the population. So what's the difference? Like a more simple model would just be start with yourself, then think of one person, think of another person, think of another person until the decision threshold is reached. And it's, I think, the same thing but simpler. So how is it qualitatively different than your model?
And the different ways to look at your question. The first question is why should there be limited search in any case? I mean, why is it costly to search for information? Yes or no? And I mean, to some extent, that's a conceptual question. And as we know from research on Q-based inference, for instance, people are selective in their information search, and they don't look always at all the information they have potentially available, but only look at particular pieces of information that are important for them to make a decision. And potentially a similar principle, that's the hypothesis underlying the social circle heuristic, also operates in these instance-based inferences. Could be that this is not the case, but apparently we find evidence that people implement these sequential and limited search. Otherwise, we would have found much stronger support for availability by recall that does not look at all the information.
But that was exactly my point,
Yes.
that because it's costly, I'm taking it a step further.
Yes.
Saying they would only keep sampling one at a time instead of a full circle of
Yes.
new people. Because I'm saying it's even more costly than you.
I mean, you were proposing that one could also implement a simple a sequential sampling model that has a particular evidence threshold, and you just search through all circles, and you could even stop sampling within a circle.
Yeah.
And that's possible. I mean, that would be a different model that you could implement here, but that would not. I mean, that was the insight that I showed from the memory experiment at the beginning of my talk. Apparently, the way our social memory works is that it is structured by these different social circles or the social categories. So it seems, or that's at least one way one can model this kind of search process, is that we use, when we are probing our memory, these different social categories as memory probes or memory cues, and we say family, boom, and then all the family members pop up. And basically, the social circle heuristic assumes that this is how the social memory is being accessed, by using these different social categories as cues for memory, and then all the instances within that circle are being retrieved. And that would be different from a sequential sampling model that would actually use, or actually need to have, a different kind of memory cue. But it would be a different model that is also possible. You can test it, and you can compare the performance against the social circle heuristic.
But there's a follow-up on that also. If you look at the circles, the number of members per circle is also exponentially distributed. Or so the first one, partner is usually one, then families a bit bigger,
Yes.
friends are even bigger, and like so. If you think about like effort allocation, you start small, and then you increasingly invest more and more effort.
Yes.
Or like the other way around, there's would start in circle 4 and then go inwards.
Yes.
That would be weird.
Yes.
Like invest like first 50 people, and
Yes.
then it's not enough, and then only 20.
Yeah, I mean, and this is exactly the nice thing about these social categories. And you could also think about other kinds of social categories that might be used to guide social sampling. These kinds of effects, where very limited sampling can or with very limited sampling, you don't pay a very high price, could work in all those cases where you have a certain hierarchy of circles, where you start with a small circle, and that could be anything basically that small, surrounded by a larger circle, and that is then increasing even in size exponentially. And that apparently is a smart way to allocate your search processes or your search efforts when you try to make inferences about the relative population frequencies. Okay, let me wrap up. So first of all, we considered, are there factors in social environments that might guide social sampling, along which social memory basically might work? And I presented some evidence suggesting that when people are retrieving or when people are searching their social memories, they're being guided by social categories that structure the people that we know of: family, friends, and acquaintances. And I presented two models, the social circle heuristic and the social circle model, that exploit these social structures not only to guide search, indicating in which order these different spheres in our social world are being searched, but also when search might be stopped. And that based on these search and stopping rules, one might even find evidence for non-compensatory limited search when people make inferences about the relative frequency of events. And finally, I addressed the question, are there particular, or might there be particular ecological structures under which such an idea of non-compensatory structured search might foster in particular well, or such limited search might benefit from. And we identified that both clustered spatial distributions and skewed frequency distribution seem to be ecological characteristics that help the social circle heuristic to perform well. And now if you go back to the mayor of Rio de Janeiro, Eduardo Pes, who relied on his own experience, actually this analysis suggests that such a reliance on a small slice of the world to make inferences about the world might sometimes actually be a smart or at least ecological rational approach. Thank you very much.